only 4% of birds in the world are thought to duet, and most of those are in the tropics. And here fish owls do. So you see the male here on the left with a big bulge, his air sacs ready, and the female's on the right. And it's a 4-note call, a call and response, male, female, male, female. Hello, my name is Jonathan Slaght. I'm a wildlife conservationist with almost 30 years of experience working in Northeast Asia and the Arctic. Most of that time has been in the temperate forests of southern Russian Far East, where I spent time working on projects with tigers and with bears. But I've also gone to the Russian Arctic and the Alaskan Arctic to work on migratory bird issues, projects that have taken me to China a few times as well. But my favorite topic is this bird here, the Blakiston's fish owl. This is a gorgeous bird, and I've spent nearly 20 years working with Russian colleagues to study this species. In 2005, I started a collaborative conservation project with these birds, which led to my PhD dissertation and a book that I published in 2020 that was translated into Chinese last year. But first, what is a Blakiston's fish owl? These are absolutely enormous birds. Females exceed 5 kilograms in size and have wingspans about 2 meters, and they stand about 3/4 of a meter high. That's about the size of an eagle. It's a non-migratory species, which means it lives in the same place year-round, and it's an endangered species, so it's protected by Russian law. The graph here shows where these birds are found. There's about 500 to 850 pairs in the world. There's a small population on the Japanese island of Hokkaido and the southern Russian Kuril Islands, but most of them are found at low densities throughout the Russian Far East. You'll notice a couple black dots in China, down by the Chiangbai Shan and in Inner Mongolia. These are historical records. As far as I know, there hasn't been a fish owl seen in China for 20 years, but my Russian colleagues and I think they're still here. This picture shows fantastic, ideal fish owl habitat. It's these river valleys with two important components. The first is mixed old-growth forest, and the second is open water, unfrozen water in winter. Now the first of these, the old-growth forest, is important for nesting. Because these birds are so large, they require huge, 200-300-year-old elms or cottonwoods to have a hole big enough for them to nest in. And the other thing they need is access to prey. These are fish owls. They're aquatic prey specialists. And they live in a part of the world where most of the waterways freeze in winter. But conveniently for them, there are natural radon gas hot springs in this area. And where the gas seeps into the river channel, it warms the water just a little bit, just enough to keep it from freezing. And those are places where the fish owls can hunt all year. Here's an example of a fish owl hunting at one of these spots. The interesting thing about fish owls is, so these are territorial birds, they're monogamous, they're long-lived, but they duet. Only 4% of birds in the world are thought to duet, and most of those are in the tropics. And here fish owls do. So you see the male here on the left with a big bulge, his air sacs ready, and the female's on the right. And it's a 4-note call, a call and response, male, female, male, female. Now, the first time I heard this call in the wild, I was surprised by how subtle it is. There are a lot of vocalizations, a deer barking, a warbler singing. These are loud. These are sounds that are meant to break your attention and listen to it. For fish owls, it's more like it's part of the landscape. It's a very subtle sound that can be really easy to miss. Young birds, however, do what I call the begging call. It is loud, and it's meant to get parents' attention. So they bring food to the chick. So among birds, I think owls are strange, right? They're adapted to hunt at night or at dawn and dusk. But even among the owls, I think fish owls are particularly bizarre. Usually, when people think of owls, there are two attributes that come to mind. And the first of those is exceptional hearing. If we look at a couple other owl species from around the world, you can see these facial discs, this feather pattern around the face, and the function of this is to channel sound directly to the owl's ear holes. And some species like the barn owl on the bottom there, can hunt in absolute pitch darkness. Now, if we look at a Blakiston's fish owl, yeah, sure, there's a little bit of a facial disc there, but it's not nearly as defined as these other owl species. Another attribute commonly attributed to owls is silent flight. And if we look at the primary flight feather of a Eurasian eagle owl, if you look at the top edge there, you can see these barbules protruding up along the top. And the function of these protrusions is to catch the air before it hits the wing and dissipate it, push the air away. And that reduces friction and allows the owl to fly through the air silently. If we look at a Blakiston's fish owl flight feather, no barbules. In fact, fish owls can be pretty noisy at night when they fly. This video here will show two things. First of all, this is a female vocalizing, so you'll hear her two notes, the ooh, ooh, ooh. Because her mate is somewhere off and you can't hear him. And then listen for her wings as she flies off. So why would owls lose these traditionally owly features? Well, again, these are fish owls. And so we need to look at what they're hunting and where they're hunting it. Most of their prey is underwater. So it doesn't matter so much to the prey if an owl is making noise in the canopy or not, because it can't hear it anyway. And as for their hearing, where they're hunting is shallow, fast-moving, rocky waterways. When my Russian colleagues and I are listening for fish owls, we move away from the rivers because it's so noisy. And I feel that if fish owls had the same type of hearing that something like a barn owl did, it might go crazy from all the noise. So these were simply features that the fish owls did not need to thrive. So the place where I've done my work with fish owls is a Russian province called Primoria, or Primorsky Krai. It's in the southern Russian Far East. It's wedged between China and the Sea of Japan. It's not a large area. It's about 160 square kilometers, about the size of Henan province. And actually used to be Chinese territory until 1860 with the Treaty of Peking. It's largely mountainous and low human population density of about 2 million people. Half of those are in one place, the capital city of Vladivostok. The rest of the population is spread out in these small villages where human population densities can be measured in the thousands, the hundreds, and in some cases even the dozens. Because of a lot of space, a lot of forest, and not many people, there's some tremendous wildlife. This is probably the most famous, the Amur tiger. But there are other things too. There's wild boar, there's brown bears, there's moose, there's Amur leopards. All of these species, by the way, are also found across the border in Jilin and some in Heilianjiang province of China. Birds here are fantastic too. The critically endangered spoon-billed sandpipers migrates along the Primoria coast. There's 3 species of breeding cranes, and there's 13 species of owls, including the Blakistons. So why are fish owls endangered? During the last century, fish owls almost went extinct in Hokkaido, Japan, due to aggressive logging of the big trees they need for nesting, which was used for paper pulp. And hundreds of dams in Hokkaido that blocked the ability for salmon to migrate upriver, thereby denying fish owls their prey. On the mainland in Primoria in Russia, there hasn't been that same conflict. These images are of indigenous Udege from about 100 years ago, and they cut down the big trees used for boats, and of course they fished. But even until relatively recently, there wasn't the same level of conflict. This map here shows just Ternay County of Primoria. It's the northernmost county and where I've done most of my work. And if you look at the road network in 1984, there were only about 200 kilometers of road in what I now know is all excellent fish owl habitat. And if we fast forward about 2 decades, look at that, an explosion of roads, nearly 5,000 kilometers of roads in just this short period of time. These are mostly logging roads. So resource extraction has really expanded into the region. And people also use these roads to go in and fish. There's commercial fishing, there's subsistence fishing, and also there's poaching. Now, what really caught my attention was the fact that these birds they're endangered, so they're protected by law, and yet there's this explosion of resource extraction and these new threats to them, but there's no bridge in the middle. There's no management recommendations because not enough is known about these birds to know how best to protect them. And so that was my interest in a PhD program and collaborating with Russian scientists. So in 2005, I met with 2 Russians, both named Sergei Surmech and Sergei Avdyuk, and put together a plan for a PhD study to create a fish owl conservation plan. That involved finding fish owls, catching them, and putting GPS trackers on their backs to track their movements, which we could then translate into a conservation plan. And we worked in a 20,000 square kilometer study area. It's outlined here in red along the coast. In this part of Russia, much of the economy is based on logging and it's based on fishing. We want to find an answer that works both for the humans that live there and for the fish owls, and science is a way to come up with those answers. So, how do you catch a fish owl? No one had really caught fish owls for science before, so we didn't really know what we were doing, and different types of raptors respond to different traps. Something that works for an eagle might not work for a peregrine falcon, and this is a fish-eating raptor, and so there were different nuances there. In 2007, Sergey and I went out into the woods in winter to try and catch some fish owls. And so this is Sergey Avdyuk. I worked closely with him for 5 years of this project. I still work with him today. He's tall, he's about my height. He has a square jaw, and his upper row is punctuated with gold teeth. He has a terrible smoking habit, but he's in pretty good physical condition. I think it's because of his lifestyle. He grew up in a small village. He was the son of a collective farmer. And when he grew up, he became an engineer at a factory. But when the Soviet Union collapsed, his job disappeared. And he pivoted to the forest and hasn't looked back. Because of experience, he knows where to cross a flooded river in a pickup truck, or when to cross a mountain pass in a blizzard. And also because of his technical skill, his attention to detail, he's also good at fixing the trucks, which constantly seem to be breaking down. And so we ended up spending months in the forest, living in tents at -30 or staying in hunter cabins, trying to figure out how to catch fish owls. And eventually, we did. Just before the 2007 field season ended, we ended up catching 4 birds. So while it started out hard, we were able to devise a system that worked, and that was a system we used to catch owls for the rest of this project. One thing we didn't know when we first caught fish owls and handled them was how they would exactly react once we grabbed them. Some species, like the sea eagles, they really try to go for your neck. Accipiter hawks and falcons, they fuss the whole time. They're always struggling to break free. But fish owls were pretty docile. I think they're large birds. They don't really have natural predators once they're adults. And I think they're unaccustomed to being handled. And they would largely just sit like this, to be honest, stunned almost into inaction. So the red circle there is highlighting one of the GPS data loggers we put on these birds' backs. All of the funds for this project were raised by grants, mostly me writing them as a graduate student. So I'd get $2,000 from one small grant fund or $5,000 from another fund. So it was very difficult each season to put together enough money to fund field assistance and food and all the logistics, and then also these $2,000 GPS transmitters. And so it was a little nerve-wracking to put this kind of technology onto the back of a wild bird and then just let it go into the forest, hoping we'd catch it again. And because these are data loggers, we did have to catch them a second time. They're not transmitters like many GPS transmitters are today. Because these birds are long-lived, because they don't really have natural predators, and because they tend to be in the same places each winter because there are only so many spots of the river that are unfrozen, we thought there was a good chance we'd be able to catch them again, and that was true. So I want to take just a little break or step back just for a moment and talk about one specific bird. This is the Shami female, so the resident female of the Shami territory. So I first saw her in 2006 when Sergey and I were driving around Primoria looking for owls where we could come back the next year and try to catch. And her territory was up this narrow logging road. It was deeply pitted and muddy. Our pickup truck could barely get up there. A smaller car wouldn't be able to. And her nest was just maybe 20, 30 meters off the edge of this road. And there were also some natural hot springs there. And this is about 16 kilometers west of the coast, right near a village called Amgu. There's about 800 people that live here, and this is a logging village. So almost everyone who lives in this village works for the logging company. And then we came back in 2008, and we saw her again. This was the first year that we caught her. Usually the way our traps are set, we keep them right next to the river. And in this case, the Shami female jumped into the water rather than away from the bank, as most of our owls do. And she got soaking wet. And it was so cold that night. It was at least -30. We decided to keep her with us overnight so she could dry off. And then in the morning, put on the data logger, feed her some fish. You can see a fish in her mouth there. and then let her go. And then the next time I saw her was the following year in 2009. She was supposed to be nesting. Went to her nest, she wasn't in there. And this guy here, this fellow with the cigarette, free climbed up the tree and found this huge piece of bark that had fallen into her nest cavity and blocked it. And so that's why she wasn't breeding. And then the photo on the right from 2010, this is the last time that I saw her. I don't know how well you can see the owl here, but that's her. You can see an ear tuft, forehead, and both of her eyes. And when we came back in 2008, the road had been widened, so even smaller cars could get up there now. And the logging company had built little huts around the Radon Hot Springs. And this was a goodwill measure for the locals who live in Namgu. They had a place to relax. And then the year after this photo, in 2011, they widened the road even further because they were planning to log further up the river valley. And then in 2012, we got word from a friend in Namgu that a dead owl was found next to this road. And she had a leg band, and from that band we could see that it was the Shami female. It's painful to think about what happened with the Shami female. I mean, I think it's already very, very difficult to be a fish owl. These are birds that live, I think, on the edge of what a fish-eating bird should be able to take. They live in a place that gets very, very cold in winter. Most of their prey is hidden from them for months and months out of the year. And then we come along, we catch them, we draw blood, we put GPSs on their backs, and we caught her probably 6 times. Once to put the GPS on, another time to take it off, once again to put it on, once again to take it off. But in the back of my mind, I knew that the work we were doing was to her benefit and to the benefit of her species, because the data that she was providing us, we'd be able to help make conservation recommendations. And so the fact that we failed her, I think, is sad. So what did we learn? Well, over 4 field seasons, we caught 12 owls from 7 different territories, about 40 times total. Again, to take put the GPS on, take it off, put it on, take it off. And this map here shows 3 different territories. There's Shami to the west in the orange. We had the male and the female. A little further south, we had a male and a female. And way up north in the blue, if you can see that, there was a male. And so we collected about 2,000 GPS locations total from these birds. And what we found was they almost never left the river valley. Less than 1% of all our GPS points were outside the river valley. And when we looked at the seasonal use of the Shami female, how she used the landscape by season, there were also pretty interesting differences. So this is winter, and you can see the big red spot. So the red is where most of her time was spent. Then yellow, some time, and green here, almost no time. And so that big red spot there, that's where the nest tree is. And you can see there's a few other smaller red spots. Those are the patches of open water. Then in spring, you can see things get a little tighter. Things really contract. And this is when she was breeding. She had a chick here. So she's spending most of her time on the nest with the chick in a much smaller area. And then in summer, look at that. The entire river is now unfrozen, so she can hunt anywhere. It doesn't matter. She's not restricted to the same spots as she was, especially in winter. And then autumn, to me, were the most interesting. Here, she's not at the nest tree site at all. She's in the upper reaches of some of the smaller tributaries of the river. And this really confused me. I showed these to Sergei and asked him for his opinion, and he thought it was obvious. He's like, look, that's where the Dolly Varden trout go to spawn. So what's happening is the fish owls are following the fish. They're going after the prey, going to where the fish are in the shallow water, spawning at their most vulnerable, where they can easily hunt them. And so using that data from the Shami female and from others, we created a predictive model of the best habitat. And so this map here, it's also from Shami. Here you can maybe see the black points, those are the GPS points. Then the green is the highest probability of finding a fish owl. Then yellow is less probable, and red is there's low chance of finding a fish owl, because we're starting to get up the slopes of the valley there. And what we found is because fish owls are so tied to river valleys, and because the whole area is so mountainous, they're only using 1% of the landscape, so a very small area. And then when we compared that to land use, we found that only 19% of the best fish owl habitat in our 20,000 square kilometer study area was protected, mostly by one reserve, the Sikhote-Alin Biosphere Reserve, whereas nearly half of the best habitat was in areas that were leased to logging. And so right there, that told us that if we want to conserve fish owls, we needed to target our management recommendations to loggers. And so our first conservation measure has to do with road planning. We took that map of the best possible fish owl habitat, gave that to a logging company. It was about 60 points in this area where loggers should avoid. And so anytime they want to put in a new road, they can refer to this map and see that there's a good patch of fish owl habitat on one side of the valley, so they put the road in on the other side of the valley. The second conservation measure has to do with road closures. You remember that map I showed you before, those 5,000 kilometers of road in the county. And so what we've done is gone and looked at which of those roads go through the best fish owl habitat, but also tiger habitat, bear habitat, boar habitat. And we work with that logging company every year to close some selection of those roads, either like this, a giant berm to block vehicular access. In some cases, they knock out a bridge to prevent a car from getting across the river. And then the final conservation measure has to do with supplemental nest sites. It takes 200-300 years for a tree to become big enough to be a fish owl nest site. As it turns out, based on our data, we found that a tree is then only suitable to be a fish owl nest site for maybe 3 to 5 years. And that's because they're big, they're old, they're rotten, they get knocked down in typhoons. The tree that Sergei's up there on the right, the cavity is still there, but it's decayed down so low, this is all almost like a chimney, and it's too deep for the owl to get in and out. And so we visited this one site called Sion. We've been going there for a decade, and we'd watched that one pair move through 4 different nest trees in that time. And in 2015, we went back, we heard the owls, they were vocalizing, but they weren't nesting. And we realized it was because they didn't have any more trees to nest in. So we took a cue from some Japanese colleagues who have been studying fish owls. And in Japan, fish owl populations have nearly tripled since the early 1980s due to very aggressive conservation measures. And one of them is nest boxes like this. So Sergei and I went to a market. We bought a number of these big 200-liter barrels that once had soybean oil in them. We cut a hole in the side of one, we painted it, attached a perch, and we drove up to the Sion territory. It's about an 8-hour drive from where Sergei lives. And we hoisted this barrel up in the tree. And we put a camera up there just to see what happened. Would the owls find it? If they did, what would they do? And it took them about a week and a half to find this barrel. And so since 2015, this pair has bred multiple times. They've fed multiple chicks in this barrel. So what's next? Well, for better or worse, I'm no longer in the field as much as I used to be. I'm now a regional director of the Wildlife Conservation Society. So my duties include oversight of our work in China, in Mongolia, in Russia, in Afghanistan, and in Central Asia. Fish owls now are a very, very, very small part of the work I do. But it's really these direct conservation intervention projects that I find the most satisfying. I mean, people in my job, we can spend our careers designing studies, collecting data, making conservation recommendations, but sometimes it's hard to know if the work we do has any real impact. But I can tell you that right now, there are fish owls flapping around Primoria because Sergei and I have strapped barrels to trees, and because we're working with a logging company to improve the management and road management. And frankly, it feels good. So what we're working on now, we're assessing reintroductions of fish owls to some of the Russian Kuril Islands, places where they become locally extinct. And we're also starting conversations with Chinese colleagues to see if we can start looking for fish owls in Inner Mongolia and see if we find some and try to assess what their conservation needs might be. And I do want to underscore that this has been a collaborative project. I feel lucky to have found someone in Sergei who was just as passionate about sleeping in the cold and getting wet crossing rivers, doing what we needed to do to collect the data to protect fish owls. And I think it's a good example. I'm saying that together as people, I think we can address conservation problems that transcend political borders. Thank you.